Okay, this is Unit 15, Lesson 1. This is about arcs, semicircles, and central angles. One of the things you need to do before we go any farther is get yourself a piece of paper and a pencil so that you're ready to write down any kind of questions that happen to come up while you're watching this. And we'll go ahead and begin with the fundamentals of arcs, semicircles, and central angles. Okay, central angle. In this case, a central angle, which is labeled angle C of a circle, has its vertex at the center C of the circle. It separates the circle into two arcs. The minor arc has the same measure as the central angle that measures less than 180 degrees. That arc is named by its two endpoints, in this case AB. Okay, so if you notice here, here's what we've got. We've got this circle. This small piece right here is arc AB. So what we're going to do is figure out what that particular part is. Okay, if you notice, the part that's not included here is actually the major arc, and that's called the major arc because it's bigger than 180 degrees, and it's named by its two endpoints and another point on the arc. All of those in the sequence in which they're encountered, as you can see here. If you start at A, go in the direction of D, and continue on to B. Okay, that's what this means. Arc ADB means to start at A, go towards D, and continue on to B. Okay, let's look at example 1. They want us to name and give the measures of the central angle, the minor arc, and the major arc. Okay, so here we have a circle. We've got this one big angle here that says it's 298 degrees. So we're going to work from that. So the first thing they want us to do is to get the central angle, which we're going to call angle C. So that's, since a circle is, the complete circle is 360 degrees, we're going to take 360, subtract the part that's not in the small angle, and so that's 298 subtracted from 360 gives us a 62 degree central angle. Okay, so since the central angle subtends this arc AB, which is directly part of it, that has the same degree measure as what the angle does. So it has a 62 degrees of arc. Okay, and then we want to get the measure of angle, or the measure of arc ADB. So we start at A, go through D, and come back to B. That gives us 298 degrees indicated directly from the diagram, so that's where that comes from. And it is the major arc. Okay, let's look at some more definitions in example 2. So the sum of all the non-overlapping central angles, in other words, those that don't have interior points in common, of a circle is 360 degrees. By the same thing, the non-overlapping arcs on the circle also add up to 360 degrees. So example 2 says they want us to find the measure of angle ACB in this circle. So ACB is this thing here. Notice that there's a 78 degree angle that's labeled ACD, and we also have the arc DB of 30. Okay, since angle C is a central angle, this means that the arc AD will have the measure of the central angle, and since the arc ADB has a measure of 30 degrees of arc, that's also the measure of the angle that's DCB. So let's take a look here and see what we got. So that means that because these two angles do not overlap, we're going to add them together to get ACB. So 78 plus 30 gives us 108 degrees. All right, a semicircle. Okay, it's simply half a circle. The diameter of a circle will separate the circle into two semicircles, and this also produces two arcs of 180 degrees each, neither of which are either major or minor. This is kind of like the number 0. It's neither positive or negative. So the 180 is kind of a neutral point. Okay, example 3, segment AB is a diameter of circle C. So they want us to find the measures of the following angles: angle DCB, arc DB, arc DBA, and angle ACB. So let's take a look and see what we got. Angle DCB is equal, since it's a central angle, it has exactly the measure that's indicated here on the diagram, which is 48 degrees. Okay, arc DB is the arc that's subtended by angle DCB, so since that's a central angle, it has exactly the same measure as the angle, so this is 48 degrees of arc. Okay, measure of arc DBA. If you look here, arc DBA starts at D, goes through B, and continues on to A. So since from B to A is 180 degrees, and from D to B is 48, we're going to add those two together to get a total of 228 degrees. And then lastly, we're looking for angle ACB, which is this angle that's formed by the diameter. So since this is a diameter and it goes all the way across the circle, it has a measure of 180 degrees. Okay, example 4, they want us to find x and then use it to find the measures of angle ACB, angle BCD, and angle DCE. So the first thing we do is take a look at our diagram. If you notice here, we got a circle that's cut up into a bunch of sections. Okay, each one of these arcs has a degree measure associated with it, but notice that none of the arcs overlap. So this means that since they take up the whole circle, that we can add up those expressions and know that it equals 360. So here's what we got. We've got x plus 2x plus 4x plus 3x plus 10 equals 360. Combine the x's and subtract 10 from both sides gives us 10x equals 350. Divide by 10 gives us x is equal to 35. Okay, so angle ACB is this central angle over here on the left side, and notice that its arc that it subtends is x degrees. So this means that we substitute the 35 in for the arc measure, and that will be the same as the measure of the angle. So the measure of angle ACB is equal to x is equal to 35 degrees. Okay, angle BCD subtends an arc of 2x. So once again, we substitute this in since it's a central angle, and that gives us 70 degrees. And then lastly, angle DCE is represented by an arc of 4x. Once again, it's a central angle, so all we do is substitute the 35 in, find the arc length or the arc measure, and then we divide. Then that is by definition going to be the same as the central angle DCE, so that's 140 degrees. Okay, hopefully if you've got any questions, you've got them written down and you're ready to take them to class with you tomorrow, and we can discuss those before we do any work. Thank you very much for your attention. We'll see you tomorrow. Goodbye.